Hello everyone. This is a tutorial on C++ programming language and on Eigen matrix library. In this tutorial, we will learn how to perform two important tasks. The first task is to save an eigenvector or a matrix to a comma-separated value file, CSV file, and the second task is to load an eigenvector matrix from a CSV file. As always, this video is accompanied by a post, and in this post I try to briefly summarize everything that I'm going to explain in this video. So if you don't have time to watch this video, let's say this is probably half an hour video, you can just go over this post, you can copy and paste all the files, you can include them in your project, and also I'm going to provide you a GitHub page with a link to these codes. The first question that we need to answer is, why do we need to dedicate a complete video to these two tasks? Well, the Eigen matrix library does not contain functions for saving a matrix object to a file and loading it from a file. Consequently, we need to write our own functions. Before we start with coding and before we start with explanations of our codes, let us first briefly summarize the CSV file format. Imagine that we have a 3x3 matrix that you can see over here. So this is a standard matrix, 3x3. Now, after saving this matrix into a CSV format, the file structure will look as follows. So the entries will be stored in this manner that you can see over here. The entries will be separated by commas, and after every row we will have a new line character, although you don't see this, right? And to show you one of the examples of the matrix stored in a file, you can observe this file. So this is a 4x4 matrix stored in a CSV format. So let us start with explanations of our codes. I'm going to start from scratch, and I'm going to quickly go over all the steps necessary to set up a project. We are using a Microsoft Visual Studio, so I'm going to click File, New Project. I'm going to click Windows Console Application. I'm going to click OK. I'm assuming that you have installed the Eigen matrix library. If you don't know how to install the Eigen matrix library, you can see one of my previous videos. The link to the video is given in the description below. So the first step is to make a few adjustments. The first adjustment we need to do is to say to Microsoft Visual Studio that we don't want to use precompiled headers. So I'm not going to use the precompiled headers. Then the next step is to include the Eigen header files into our project. So how to do that? Well, under the general option, there is a section additional include directories, and we can specify over here by performing the steps that you can see over here. We can specify the path to our Eigen header files. In my case, the header files are located over here, and you just need the root directory, and you click on select folder and you click on OK, and you click on apply and OK. Fine. Now we can start with coding. Okay, so let us first erase the parts of the program that we don't need. We are going to erase these comments, and we're going to erase these two lines, and here we don't need these parts. Okay, now in interest of time, I'm just going to paste some parts of the code that are kind of standard and a little bit boring. So I'm going to include the input-output stream header file. I'm going to include the Eigen dense header files. Since we are talking here about dense matrix computation, I need the fstream library, and I need the standard C++ vector header files. Then I'm going to use the namespace std, and I'm going to using namespace Eigen, such that I don't need to, such that I can simplify the notation. Great. Now, the next step is to define the function that will save a matrix object to a CSV file. This is relatively straightforward. This is not complex operation. So I'm just going to paste the function I wrote. So here it is. And we're going to briefly explain this function. So this is the function I defined. It's called save data. It has two input arguments. The first argument is the string describing the file name. In our case, for example, this can be, you can call this file matrix dot comma separated values. It's your own choice. This is the string. And the second input argument is the Eigen matrix object. This is a dynamic Eigen matrix object, and it's the entries are double. This D means that the entries are doubles. Okay, now first we need to specify the output form, the input-output form. You can look online and you can find basically Eigen web page that describes these input-output formats. What is important for us is that we want full precision, we don't want to align columns, and we want to separate the entries by commas. So this third parameter means that the entries will be separated by commas, and at the end of the line we are going to place an end of the line character. Okay, and this is enough formatting, and we can basically very easily save our matrix into CSV form. Okay, the code line 15 is used to create an output file stream with a specified file name. Then here, if the file is being opened, perform the operation. So what is the operation? We are going to take the matrix, the Eigen matrix object, we are going to format it according to specified form, and we are going to save it into the file. So this is simple as CO_out or CE_in. So there are analogies between CO_out and CE_in, and this is an overload, of course, this is an overloaded operator. And finally, we are going to close the file. This was very simple. The next step is to define a function that will load the CSV data and convert this data to an Eigen matrix format. This is a more complex task. And again, I'm going to paste my function, the function I wrote, and I'm going to explain it. Okay, so this is the function open data. The input parameter is a string object specifying the name of the file. And the output is an Eigen matrix object, dynamic matrix, and D means doubles. Now, let us briefly explain the procedure of converting a CSV file into a Eigen matrix object. In order to properly understand the code, it is first important to understand the general procedure for converting a CSV file into an Eigen object. So, this is an example of a matrix stored in a CSV file. The code works as follows. We are going to read this file line by line. So we are going to read, let's say, the first line, and we are going to store this line into a vector object, a C++ vector object. So the C++ vector object will have the following structure, will contain the first line. Then we are going to read the second line, and we are going to store the second line into a C++ vector object. And finally, we are going to read the third line and store it into the C++ vector object. Good. Once we have a vector object, we are going to map this vector object into an Eigen C++ matrix object. So how to do that? Well, we are going to use the Eigen map framework. So Eigen map framework or function converts an array. It can be a C++ array, it can be a vector object, a C++ vector object, or an ordinary array into an Eigen object. So once we have a vector, we will specify in the map function the address of the first entry of the vector, and we are going to specify the matrix dimension. So we are going to provide as an input the address of the first entry. We are going to provide the number of columns, actually the number of rows and the number of columns. And we are going to specify what type of Eigen C++ matrix we want to have. We want to have a dynamic matrix of double and some other parameters that are not important. So the procedure is start from a CSV file, create a C++ vector object, just store the matrix entries row-wise, and then use the map function, the Eigen C++ map function, to map a vector into an Eigen object. Okay, so this is our function open data. We provide the string file to open, which is the name of the file. Now, here this vector is the C++ vector object used to store the matrix entries. Then here we read the file as an input file stream object. The file is now loaded as a stream. This variable is used to store the row of the matrix that contains commas. So we are going to read the file to open line by line, and we are going to store every line into this variable. And this variable, actually this string matrix entry, will be used to store the matrix entries. And finally, we need to define a variable that will track the number of rows of a matrix. The code line 58 is used to load the first line, let's say in the first execution of this while loop, the first line of the matrix data file, now this is a stream, watch out, this is a stream, will be loaded into matrix row string. Okay, then we need to convert the matrix row string into a string stream such that we can easily read the characters stored in the matrix row string. And here with this code line 62, we basically read now the string stream, matrix row string stream, entry by entry, although this is a get line, this is done, this while loop reads every entry of the matrix row string stream until the comma value is being found. Okay, until we find the comma, we store every character actually in the matrix row string stream into this entry, and with the code line on 64, actually the code line 64, we convert the character, the matrix entry, into a double format, and we fill in the matrix entries vector. So with pushback, we just fill in the matrix entries vector, and we keep on doing this procedure. Once the first line is finished, we start with the second line. We read the second line in the matrix row string, then we convert matrix row string into string stream, and then we read the converted matrix row string stream entry-wise and store all the entries in the matrix entry. Comma is used to delimit the numbers, and finally we just complete our vector. We just store all the values in the vector, and this is what happens. The first row is being read, fill in the vector. The second one, fill in the vector. The third one, fill in the vector. Here it is important to mention that we always keep track of the matrix row number. So we keep track of the number of rows in the input file. Why this is important? Well, this is important for the code line 71. And the code line 71 is our map function used to map the vector storing the matrix entries into an Eigen object. And here we need to specify for conversion matrix row number, and we need to specify the number of columns, and the number of columns is the size of the matrix entries of this vector. It's the size divided by the number of rows. So we don't need to keep track of the number of columns. We can just divide the total size by matrix row number. And here we need to specify the pointer to the first entry of the vector. Why this is important? Actually, why this whole procedure works? Because the entries of a vector are stored consecutively in the computer memory. And this function just needs to know the pointer to the first entry, and it needs to know the dimension of the final object. And it automatically converts our C++ vector into the Eigen matrix object. Good. So let us test this code. I've wrote here a simple driver code that I'm going to paste right now. So here is our driver code. So what do? First, we define an Eigen matrix object. We say it's going to be a matrix 4 by 4. We fill in the entries. Here is how we fill in the entries. We fill in the entries row-wise. Then, here we call our function save data. Good, we save the data. Then we want to see, is the procedure correct? So we are going to load the saved matrix. Again, we are going to define another matrix, and we are going to call our function open data, specifying the name of the file. Notice here the name of the file I used to save the data. I'm going to use the same file. And finally, I'm going to print the matrix in console. Okay, so let's build this project. and let us run it without debugging. Good. So here is our matrix that is being loaded from the file, and this is the matrix that is being saved into the file. So things perfectly match. Of course, we can always inspect our files. So here's the folder. The matrix files or the CSV files are saved in the main file of your project. So here's our file, and we can open it up, double click. Actually, it recognizes it as an Excel file, although it's not an Excel file, but here it is. Here are our entries, and we can also open it as a text file. So here is our text file, and let's check it. Perfect. So the conversion works. Of course, we can further test this conversion, and I'm going to do it right now. I'm going to use another file I created manually. So in this folder, you can see this file called matrix outside, and I can manually define right now a matrix. I can specify 1.1.3, 0.7, enter. Enter means a new line, although you don't see it in this file. This character is being memorized. 0.1 minus 0.1. Okay, don't type enter, and then you can save this file as, just save it, but you can also save it as, the error here shouldn't be saved as a text file. You need to specify here that it's a CSV file, and you can save it. Fine, this is our file. Let us now see, will our code be able to load this file without any problem? Here again, we define the third matrix. We load the data from the matrix outside into this matrix, and we print it out. Let's see what happens. Okay, I'm just going to close these files. Okay, there is an error. Let's see where is the error. Okay, I found the error. The error was, of course, trivial. The error comes from the fact that I saved the original file into the folder of another project, so my code was not able to find the file. Just to show you this, I'm going to reproduce this error. I'm going to start without, oops, I didn't want that. I'm going to start without debugging. Here it is. Okay, so you'll get an error. Some code, right? We can look into this code, but we don't want to do that in interest of time. So the problem is that in this folder of this application, we cannot find our file. So the file was stored somewhere else in my previous project. Here's our file. I'm just going to copy and paste it over here. Here it is. Let's just verify that everything is fine. So this is our matrix defined, let's say, notepad, and let's see now what happens. Here it is. Here is our matrix. So the code works very, very well, and it's quite reliable. I tested it in another project. I'm going to post this code on GitHub, and in my future video I'm going to integrate this piece of code with a more complex code, and this code will be used to simulate a dynamical system, to save the data to a file, to transfer this data to MATLAB, then in MATLAB to perform some computation, and then to save the results in MATLAB to CSV file, and then to load them back into the Eigen C++ environment. Thank you very much for your attention. I hope you enjoyed this video and stay tuned for more videos.